Hello, 4th grade. I hope you're doing well. Today we are going to be continuing our study of simple machines, and we're going to be adding one more simple machine to our list right now. But before we do that, I would like to review what we know about simple machines so far. So if you remember, simple machines are devices that help us apply force, and they usually help us apply it in more efficient ways. If you remember that equation, work equals force times distance. Simple machines let us do the same amount of work, but we either change the force or the distance to make it more efficient. So if we increase the distance of something, we can decrease the force, or if we want to increase the force, we can decrease the distance. So it helps us get a mechanical advantage in applying force to things. And here's our list of the simple machines again. And we're going to be adding one of these to our list of ones that we know today. Let's also review the specific machines that we talked about. We talked about the lever first, and the basic takeaway principle is that a longer lever arm, it increases the distance, but you use less force when you do that. And with a shorter lever arm, you decrease the distance, and then you need more force to move a load. And again, we're manipulating that work equals force times distance equation. In our last class, we learned two more machines, and those were the inclined plane and the wedge. Now, an inclined plane, if you remember, is basically a ramp, and it basically makes it easier to move things up and down by increasing the distance. So rather than this man here moving the wheelbarrow straight up to that ledge, which would take a lot of force, even though he doesn't have to move it very far, he increases the distance so he doesn't have to apply as much force to it. So if he spreads out the distance over the course of this ramp, then suddenly it's much more manageable, and he can just push the wheelbarrow up the ramp rather than just lifting it straight up. So he increases the distance to decrease the required force. We also learned about a wedge, and a wedge, you can think of an axe. It's something that it looks like a triangle, and it basically allows you to convert a forward force, or say a downward force, into a sideways force. And it's often used for splitting things apart. So you can use a wedge to split open pieces of wood, or when you cut something with scissors, you're putting wedges next to each other, and you can cut open paper and all sorts of stuff like that. So there's lots of good ways of using wedges to split things. And today we're going to add a new simple machine to this list. And that simple machine that we are going to add is going to be the wheel and axle. So we've already talked about the three on the left over here. And now we're going to be talking about this one on the top right here, the wheel and axle. So, I need to picture for a moment a screw that has been screwed into wood. And a screw is a different simple machine, but we're not going to be talking about that today. So, my question for you is, have you ever tried to unscrew a screw with just your hands? So like there's a screw in a piece of wood, and you take it and you're trying to unscrew it using your bare hands. No tools allowed. If you have tried that, you'll remember that that's very difficult. If you have not tried that and you happen to have a screw in some wood, you can go ahead and give it a shot. It's actually very difficult to screw with just your hands. And you probably were unable to actually budge the screw at all, unless it was already pretty loose, then you could probably work it out. But no matter how hard you push and you twist, it's really hard to get that screw out. And that's partly the design of the simple machine of the screw, but also because we are not using the tool that is designed for screwing and unscrewing screws, which is our trusty screwdriver. So if you have ever tried to unscrew or screw in a screw using a screwdriver, you will find that it's much easier than using your bare hands. You just grab the handle, you stick the end in, and you twist, and then suddenly it's much easier. And there's a couple of reasons for that. One is that the end of the screwdriver actually has the shape of the screw, so you get more of kind of a grab on the screw, which helps. But even more than that, a screwdriver is actually an example of this new type of simple machine, a wheel and axle. And you'll learn which part is the wheel and which part is the axle. You probably don't think of a screwdriver as being a wheel, but in fact it actually is that same kind of simple machine. It can also be used as a lever and other things. But enough on that right now. So, a wheel and axle, its basic shape looks like this. It has two components, the wheel and the axle. Now, the wheel is the thing that looks like a wheel, looks like a tire. It's the larger disc-like part. It's the thicker part of the wheel and axle. And so the wheel is a thick kind kind of usually round thing that's stuck on this axle. Now the axle usually goes right into the middle of the wheel. Just like in your toy cars and in real cars, we have real wheels, you have this metal rod or something going right into the middle of that wheel. And that is called the axle. So when the whole wheel spins, the axle will spin as well, because they're attached. It's not like the wheel is spinning on top of the axle. They're attached, so when one spins, the other spins as well. So this is one simple machine, the wheel and axle. Now, the fun thing about the wheel and axle is that it gives us a mechanical advantage using something called torque. And now let me go ahead and define what torque is, because that's a sciencey word, and when you get into more advanced physics, you'll see that show up a lot more often. But torque is basically what I'm going to call a twisty force. So it's how much force you have with twisting motion. So in the screwdriver, you're putting torque on that screw and twisting it out. Or in a car, when it drives, you're putting torque on the tires to get them to spin. So it's kind of a twisty force. It's not a force where you're just like pushing something forward, you're pushing something to make it twist. So it's a little bit of a different kind of force, but it works very similar to all other forces. And so you could just think of it in terms of a twisty force. So it would be represented perhaps by the arrows here. That could be a twisty force being applied to the wheel here. Okay, so let me give you some examples of the wheel and axle, and this will help you to understand how it works. The first example is the screwdriver. Basically, the way a wheel and axle works is it's easier to apply a twisty force. It's easier to apply torque when you have a bigger circle that you're going around. So if I'm applying torque around a bigger circle, it's easier than if I'm applying it around a little circle. So with my screwdriver, because the handle is thicker than the screw, it's wider circle, it's easier to twist that around than the screw itself. And this is that same equation that we have come to love, that work equals force times distance. Really what we're doing when we're using a wheel and axle, and we're, say, twisting something, say the handle of a screwdriver, we're increasing the distance that we're actually twisting, so your hand is moving more, but you're decreasing the amount of force that you have to use to get that same torque on the screw. So that is the mechanical advantage of a wheel and axle, and in this case the screwdriver, that the handle makes it much easier to twist the screw out, because you are increasing the distance and thus decreasing the force that you need to exert on it. Some other examples are a doorknob, something you use perhaps every day. If you notice, on the doorknob, especially one that's in this shape, you have this nice big circle part that your hand grabs, but then going into the door, there's a much thinner part. So the wheel is actually the doorknob, and the axle is that thin part that goes inside. And if we had X-ray vision, we could see inside this door. We'd see that when we twisted, that axle that goes in actually moves stuff, which moves the little latch here, which then opens the door. So when you use a doorknob, it's much easier to twist the doorknob than to twist just an axle. So like imagine we had just a stick coming out that you had to twist. You'd actually have to put a lot more force into it in order to open the door. But being that we have knobs, it makes it a lot easier, which is very nice for us. Another example is going to be any sort of a vehicle, like this Ferrari here, or any other car or wagon or bike or unicycle. The engine is burning gas and producing energy, and what it does is it ends up applying a force to the axle there, and it'll end up spinning both wheels. So we're using this spinning motion to make the wheels move, which will make the car go very fast. So vehicles use wheels and axles all over the place. And that's another advantage of a wheel, is it enables you to roll things along, and then you can get past friction a lot easier. So imagine if, say you have a big box that you have to push somewhere, and it's just a big wooden box, and you're just pushing it along the road. It's going to scrape against the little rocks in the road and against the pavement, and there's going to be a lot of friction between the box and the road, making it very difficult to push. But if we put some wheels on the bottom of the box, suddenly it's much easier to push, because the wheels don't pick up as much of that friction. They just kind of roll along the surface rather than scrape against it. So wheels enable things to roll very efficiently, and so that's why we can use a car to travel very well, and because it just rolls along. It's not like it's a big box that's just scraping along the ground. That wouldn't work too well. Another example is a toy top. I assume that you guys have used a toy top. It's a toy that I used to use when I was a kid, and I don't know, maybe they're not popular anymore. But basically what you do is it's this little stick attached to a bigger circle piece that has a little point at the end. What you do is you kind of flick your fingers and you spin it around real quick, and it just stays upright for a long time on the table. You see how long you can get it to spin. And this is using a wheel and axle in kind of the opposite way that we would use the screwdriver, or that we would use a doorknob. The part that we actually grab onto is the axle. So that little stick coming up is the axle, and the rest of the top, the wider part, is the wheel. And so what happens is when you flick it and you kind of spin it, you're spinning the axle. And it's pretty easy because it's a very lightweight toy, but when you spin that around, the wheel part, the actual top, spins much, much faster. Because for every time the smaller piece goes around, the bigger piece will go around as well. So if you spin the smaller piece real quick, the bigger piece is going to go really, really quick. And because of that, spinning motion actually stays upright because of physics. And that's where the fun of the toy is. It kind of stays upright in that position. So that's another fun example of a wheel and axle. One thing I would like to point out as well, and this might help you to visualize in your head how a wheel and axle works, it's actually kind of like a lever, which might seem surprising because it doesn't really look like a lever. But to demonstrate this, I'm going to show you a different kind of doorknob. So down here on the bottom right is a doorknob that we've already seen. It's that circle doorknob. But on the bottom left, we have this doorknob that has kind of a handle on it. Now, both of them end up producing a twisty motion, but the one on the left is more like a lever, isn't it? And basically what happens is the longer your lever arm is, the easier it is to push. The less force is required, but you have to push it farther, a farther distance. So like if you were to push at the very inside of the door handle, your hand wouldn't move very far, but you'd have to push harder, versus the outside, your hand would move a lot farther, but you'd have to push not as hard. So you can kind of think of a wheel and axle like a lever, where the wheel is kind of the lever arm, and the axle is kind of the twisty motion you get right at the fulcrum. It's easier to produce that twisty motion with a longer arm, but you can't get it to go as fast. But if you get real close to that axle, to the fulcrum, you don't have to push it very far to get it to move fast, but it takes a lot of force. So you can really think of a large wheel as just a longer lever arm. So the bigger your wheel is connected to your axle, it's like a longer lever arm that's going to be easier to twist, but you have to twist it. Your arms have to move farther as you twist it. I don't know if you've ever been on docks where you see those big things where you can actually lift a boat up out of the water twisting this wheel. That's kind of the same idea. It's a wheel and axle. You're able to twist this boat up using this great big wheel, but you have to twist it many, many, many times around. So you increase the distance and decrease the force. I would like to also mention that this idea of a wheel and axle applies to something called gears. Now we're not going to get a lot into gears right now, but you've probably seen them before in maybe cartoons, or if you've ever taken apart one of your toys or something, you see these little wheels that have teeth all around the outside that connect with other gears, and when one twists, they all twist. So we can use gears as wheels and axles to make motion more efficient. And this is how a bike works. If you ever ride a bike where you actually change the gear, this is sort of like what you're doing here. If you look at this diagram here, we have an axle connecting two gears. And those, you can pretend that it's all just stuck together. It's not like they're twisting on top of it. So when one twists, the other one twists as well. If we twist the small one, the larger one is going to twist at the same rate, but because it's a bigger circle, the outside is actually going to move faster. And likewise, if we were to twist the outside one, because it's connected to the small one's going to turn at the same rate, but because it's a smaller circle, the gears are actually going to move a little bit slower because they're on the inside, that smaller distance from the axle. So we can use this to change how efficiently machines work. And this happens in cars and in bikes and everything. So in bikes, when you turn it down to a lower gear, you're making it so it's easier to pedal, but you have to pedal a lot more. It's that same force times distance equation. Versus like when you turn into a high gear, it becomes very difficult to pedal, but for every pedal you push your bike really far forward. You apply a lot of force, but you don't have to move your feet quite as fast. And so depending on the speed that you're moving, using different gears can be helpful. This is also what you get in cars as well, especially the old stick shift cars. You actually have to manually put it into different gears. But in modern cars, you can even hear it as, say, your parents are driving and they accelerate, and you hear it going, it's putting into different gears for different speeds so that the car can be the most efficient for its engine energy output compared to the speed. And there's a lot of science behind that I can't get into right now. But just know that wheels and axles apply to gears as well. Now, that is all that I have for this lesson right now, and I hope that you enjoyed it. Once again, keep your eyes out for simple machines. In the next week or two, I'm going to be doing some maybe more activities with the simple machines. Now that you know what more of them are, we can actually start thinking about like maybe using them and doing fun things with them, or at least seeing them being used around us. So you can get excited for that, because that'll be coming here pretty soon. Anyways, I hope that you enjoyed this video, and I hope that you all have a wonderful weekend, and I will see you next week.